Hello, everyone. This is Maurice McHugh with the GOZAR Product Readiness and Operations team, and I would like to welcome you all to the Satellite Book Club Seminar Series, session number 221. Today's presentation is GREMLIN and its use at the National Weather Service Forecast Office in Pago Pago. Today's presentation is by Kyle Hilburn from CIRA and Scott Lindstrom from SIMS. Our facilitator today is Brian Curran, Science and Operations Officer from National Weather Service, WFO, Midland, Texas. Before we get going, just want to remind you that the session is being recorded per the OCIO Privacy Act guidelines. Please ensure that your microphone is muted and webcam off throughout the session. See the pinned message in the chat for more information. The Q&A section is going to be after the presentation. I would like to encourage attendees to post their questions in the chat room, and they will be fielded through there. If you are logged in under an alias account, please sign in with your full name or specify your full name when asking a question in the chat. We are always looking for future presenters. Please feel free to contact the TOWERS team if you're interested in presenting. And our training team can help create training materials that may be otherwise unavailable. Please contact Ross Van Til for information or questions on that. I'd like to say a few thank yous, first of all, to the OCLO, the GEO and LEO programs, and our facilitator for today, Brian Curran. Our presenters today include Kyle Hilburn, who has completed a Ph.D. in atmospheric science at Colorado State University in 2023, with a dissertation focused on developing and understanding an artificial intelligence model for generating synthetic radar reflectivity from the GOES satellite observations. Currently, Kyle is a research scientist at CIRA, and he continues to develop quantitative applications of satellite data for improving monitoring and prediction of weather-related hazards. Scott Lindstrom grew up about a mile from the Penn State Meteorology Building. He eventually received 2 BS degrees from Penn State. He went to graduate school at UW-Madison, where both of his parents and all 4 grandparents graduated as well. Scott creates training documents, quick guides, blog posts, and visit training in collaboration with FDTD and National Weather Service. He also enjoys looking at beautiful satellite imagery and explaining the benefits of using it. Kyle and Scott, welcome back to the Satellite Book Club, and please take it away.
Okay, thanks. This is Scott. I'm going to start. So this is how the forecast office in Pago. We're looking at the Pago Pago harbor right there in the background of this. Eric Jacobson at the bottom of the authors is a Pacific region, and the list of people in the middle are forecasters in the Pago Pago office. Next slide, please. So I thought I'd start with a little geography lesson. In case you're not familiar where American Samoa is, it's in the South Pacific, 14 degrees south, 171 west. If you ever want to visit, I highly recommend it. You fly about 5.5 hours south out of Honolulu. Next slide, please. The American Samoa has several islands. The main one is Tutuila, which is where the forecast office is next to the airport. And Pago Pago is the main city that is on the harbor. But there are also those smaller islands, Olosega, Ofu, and Tao to the east of Pago Pago, also part of their forecast. Next slide, please. The challenge for forecasting for an island, of course, if you're off by 5 miles, you're 100% wrong. So I find when I visited there, it's a very challenging place to make a good forecast. Next slide, please. So why do they have satellite data? I'm going to read this quote from the MIC there, who's Eleanor. As an office that relies heavily on satellite data due to the lack of a weather radar in American Samoa, so it's the only forecast office in the Weather Service that doesn't have a radar, GREMLIN has been a vital tool in our forecasting and hazard monitoring efforts. Actually, I won't read the whole thing. You can read the whole thing. But this is a product based on satellite that's very useful for a forecast office that's in the middle of the Pacific Ocean, and therefore doesn't have either a lot of conventional observations or radar data to help with making impact-based decision support forecast products. Next slide, please. So what do the forecasters have there? Do they have radar? Nope. Do they have direct broadcast satellite imagery? There are WFOs out there that do, like Guam and Puerto Rico, Honolulu, other forecast offices on islands, but American Samoa does not have direct broadcast. Really, all they have is 10-minute full disk imagery. From both goes west and from Himawari 9. So Himawari 9 also shows American Samoa is also within the Himawari 9 footprint. They do have the ability to call mesoscale sectors, and those are called pretty often, especially for heavy rain. Next slide, please. Rain is the main forecast problem in Pago Pago. So their wettest year, 191.4 inches, was in 2020. And you see the list of rainfall totals for 2020 there. The mean rainfall there, I think that exceeds the record rainfall for just about any station in CONUS, Alaska, or Hawaii. Maybe Hilo has a heavier, maybe Hilo has a record rainfall that's greater than the mean rainfall in Pago Pago, but it is raining there a lot. So how much rain have they had so far this month? It's a little bit above normal, 24.63 inches through yesterday. So rain is really the forecast issue there. It's a very mountainous island, so flash flooding and landslides are a problem. Next slide, please. Oh, take it away, Kyle.
All right, thank you so much, Scott. What is GREMLIN, if you're not familiar? The acronym stands for Goes Radar Estimation via Machine Learning to Inform NWP. That was the original use case for GREMLIN, was about initializing high-resolution convective scale forecasts. But as part of this presentation, you can see we're expanding its uses to other applications, including flood forecasting for Pago Pago. So GREMLIN is a machine learning tool. It was trained on MRMS radar over the GO16 CONUS domain. And so the inputs to GREMLIN are 3 bands from ABI. There's the shortwave IR, the water vapor band, and the longwave IR. And then there's also lightning information from GLM, specifically the group extent density accumulated over a 15-minute period. Actually, a 10-minute period for the product we're talking about today in order to match the 10-minute full disk cadence. So recently the product was demonstrated, or I should say a year ago, it was demonstrated at HWT, where we provided it through AWIPS, AWIPS in the cloud. And so worked to get it from Tower S, the Pacific region. You can see thanks here to Brian Rapp, Lee Byerly, and Eric Jacobson. Next slide, please. So if you really want to know more about GREMLIN, the place to start is the quick guide. Here's a screenshot of the quick guide and a QRC code with a link so you can download the guide. It talks about the inputs, it talks about its strengths and weaknesses, and it provides links to 3 papers on GREMLIN which talk about the algorithm itself, some interpretable and explainable AI work with GREMLIN, and then a validation. Next slide, please. So just a very quick sketch of GREMLIN. This is a convolutional neural network. You can see the model architecture, a graphic there on the right. It has a U shape. It's in the family of U-nets. So this is the type of architecture that does image-to-image translation, where the inputs I described previously are from ABI and GLM. And then the network translates those to produce outputs trained to the MRMS composite reflectivity or vertical maximum reflectivity product. I think that's my last slide.
Yep,
I'll hand it back over to Scott.
Thanks, Kyle. So I just want to show you a couple of examples of how this might be used in the office. This is one from September of 2024 when I was actually on island with Eric Jacobson and Eric Lau. So we were doing a site visit. So if you're looking at this visible imagery, maybe you're picking out regions where there's rain just based on the cloud structures. I have an arrow there pointing to Tutuila, and then we have the two islands of independent Samoa to the west. Next slide, please. If you look at the gremlin animation for the same time, you can see it's picking up really nicely where the rain and where the heavier rain is falling. So if you're if you're on an island and you're concerned about flash flooding, and you see that kind of yellow and red region approaching from the northeast, maybe that's a time to sound some alarm bells. And also importantly, if you look to the north, since the cloud motion is mostly from the northeast, there's still a lot of gremlin returns off to the north, and just a whole bunch to the south as well as you get deeper into the South Pacific convergence zone. So that's, that's kind of why Pago has such heavy rain, is it's frequently within the SPCZ and the rain that produces. So next slide, please. So if you look at the side-by-side images at 2110 UTC, the visible image on the left and the gremlin estimates on the right, I think you see a nice representation of where the heavy rain is, and it's on Tutuila and also over the smaller islands to the east. I was at the airport at the time, and I went outside and took a picture. So I'm looking east from right here. So maybe seeing part of the structure of this cloud in this picture that I got from my phone. Next slide, please. So by 22Z, the forecast office had issued a flash flood warning because the satellite indicated the heavy rainfall over the islands. So it's imminent or already occurring. And again, this is the chief problem that the forecast office there is facing from day to day, is where will the heavy rain be? Where will the rain be? And if it rains, will there be flash flooding? Next slide, please. So later that day, so we were looking at, I think, 20Z before, now we're looking a couple hours later. You see there's still convection forming. This is a visible imagery, bit of a different aspect ratio to it, but you're still seeing convection forming to the north. And you might ask, well, is there any rain with that? So let's go to the next slide. We'll see the gremlin estimates from it. So again, this is what a radar might look like, but it's based on the satellite data, and it's showing the heavy rain. Still, a lot of it is to the south of Pago Pago. Hopefully you've picked it out here. You know what it looks like. There's Tutuila, but there's still rain forming up to the north. So next slide, please. Another flash flood warning was issued just after the end of that particular animation. So they're using this product pretty effectively to help give them flash flood warning guidance. Next slide, please. This is also a product that if you are a follower of the forecast office on Facebook, and this is a method of communication that a lot of the Pacific region forecast offices use to get their message out. You don't have a TV station there, I don't think, but a lot of people on island have access to Facebook. So here we have an example where possible areas of heavy rainfall are listed. This is also from September 6th. I think it was actually in one of the animations you just saw. And it's saying, look where it's raining right now. Be aware of this and look out for flooding. Next slide, please. I actually have a whole lot of these. So they use them if heavy rain is approaching. So on the bottom there, Talofa, American Samoa. Some things I learned when talking to people in American Samoa, the Samoans do not have a C in their language. So you'll frequently see a K for the C. So their current tells you what they're doing. They're monitoring these thunderstorms. The heavy rain is approaching. So I think it's a great graphical way to tell the public, here's something that's coming toward us. You better be aware and make plans for it. Next slide, please. And like I said, that one was actually a video on Facebook. I have a lot of examples here. So here we have it where the showers are moving south and away from the territory through the day. So they're showing where's most of the rain happening is south of Tutuila, but there's still a little bit to the north moving in. Next slide, please. More and more. So areas of heavy rainfall. So this one says green, blue, and yellow colors. So, you know, for me, used to looking at this, I thought, well, yeah, just put the gremlin out there because, duh, it's green, so that means it's rainfall. But someone new to the office pointed out, well, you know, the public's not necessarily going to understand the relationship of the color to the rain rate. So it's always great to get a reality check like that, that what you understand intuitively, the public is not going to understand intuitively. So that's a more basic message than just using Gremlin. That's valid for everything. Next slide, please. So you can see that there are just lots and lots of examples of this where the forecasters are using the product, here, next slide, please, to broadcast information to the public saying, okay, we have information from the satellite that there is a lot of rain around us or heavier rain is approaching us. Next slide, please. And you can do it at small scales like I just showed you. This is a very large scale view over the entire basin. So you can see Fiji here, here's Australia, a low pressure system moving toward New Zealand. And we have the rainfall associated with the SPCZ just to the north of the Samoan Islands. So it's a great way to tell people in a picture what the rain is going to look like, what the rain might look like, based on the Gremlin estimates. Next slide, please. And I think I'm running out of examples for you, not that I couldn't have grabbed more, but again, showers and thunderstorms will remain in the area through Monday, and a person looking at this will see the distribution of that rainfall and recognize, oh yeah, it's not raining constantly. It will stop raining sometimes as this moves over us, but there will be periodic times of rainfall based on these satellite estimates. So it's a great, like I said a couple times now, it's a great way to inform the public of exactly what kind of rain you might be having in the short term. Next slide, please. Just another example, this one's from July, where the thunderstorms are moving toward the Samoan Islands, and it's showing their distribution, their horizontal distribution, and their motion. Next slide, please. Let's go to the next one. So, that one had a flood watch. You might have seen Gremlin at the AMS talks. Eleanor, who is the MIC in Pago Pago, had an e-poster, and this is a screenshot from Pam Sullivan's talk on using this Gremlin data product over American Samoa. So maybe you've seen that inset picture once already in this talk. So it's out there. It's being used in Pacific region, I think, to great effect. Next slide, please. And I just wanted to alert people, you can find this online. It's on the CIRA slider. So if you can see, there are Gremlin cases that I've documented on the Sim Satellite blog too. So one of my jobs is to help Pago Pago better utilize satellite information, and what better way to use it to do that than to use a product that simulates the radar that they do not have. Next slide, please. So what's the timeline for this? So, Kyle created the product. That was step one. People in AWIPS got the product into AWIPS for HWT. Kyle was there and I was there. So I saw this HWT and I thought, well, this would be a pretty cool thing for Pago Pago. This was last May or June in Norman. So then Tower S and Eric Jacobson at Pacific Region worked on how to get the display in AWIPS in Pago Pago. That was really fairly quick. It was about 6 weeks between the initial request and the product appearing in the AWIPS in Pago Pago. So that was really pleasant to see how fast that happened. And then I've been creating blog posts to show the examples that I then forward on to Pago Pago for training purposes. And then I visited, like I said, you really have to visit the island. It's beautiful. Just to emphasize its importance in daily use. And the beauty of that was when we were there, it was just pouring down rain one of the days. And so people would go outside and get wet. And of course, you'd say on the way back, when they came back in, well, did you look at Gremlin before you went outside? So this is a really nice cooperative endeavor between CIRA, SIMS, the Weather Service, and NESDIS to get this product out there where it can be used. Next slide, please. You can access it, like I said, on Slider. It's in the Amazon, it's in the cloud. So there's the Amazon Web Services link for it. Next slide, please. And people to contact are listed here. We're all at noaa.gov. Happy to answer questions. And thanks.
Hey, y'all, this is Brian here. If you're an attendee, and obviously you are, please stay on the discussion, especially those who are in field forecast offices of regional headquarters. We also encourage everyone to change his or her meeting layout to tiled and select tiles without video. I want to remind attendees to submit questions or indicate if they want to ask a question verbally in the chat room. And Emily has got the links there. Oh, we've got one from Jose Garcia Rivera. Here's a question. Great presentation. Are there any plans to leverage microwave platforms such as AMSR, GPM, Tropics to enhance Gremlin products?
Yes, that's a great question, and the answer is yes, because as you know, over the ocean there does tend to be less lightning. Lightning is a very important predictor for Gremlin. So to be able to make up for that to a certain degree, microwave adds a lot of value. So there is work currently looking at how to do that best.
Cool. Matt Gernshore asks, sorry if I missed this, but is Gremlin parallax corrected?
Yeah, that's a great question. So when I originally developed the product on the herd grid, I did apply parallax correction. When we implemented this on the full disk, I did not apply a parallax correction. I find that most forecasters are familiar with looking at ABI and can mentally adjust for that. That said, though, for version 2 Gremlin, I'm adding the input so that the model actually learns the parallax correction in order to reduce those, having to provide, do that mental gymnastics when you interpret it.
Benjamin, I see you have your hand raised. What you got?
Yeah, great presentation. I am up in Alaska, and we are very radar sparse up here, as I'm sure you guys know. So I'm curious if you guys think there'd be any applicability up here, and if so, we'd be excited to try to test it out.
Well, Ben, we could take a look with the caveat that ghost pixels are pretty big at that latitude, and you do run out of GLM coverage. So, I think really the ideal product over Alaska would leverage other LEO assets that have the same channels on it, maybe bringing in the Alaska Lightning Network. So I think it would take a little development to provide the ideal product for Alaska, but yeah, I understand you don't have good radar coverage up there, and I think a product like this could be helpful.
Yeah, and if you go to the CIRA slider, because of the lack of GLM coverage, you'll notice that Gremlin ends so close to Alaska, but it does end.
Okay, I see that Ian Arvich had asked a question, but Joseph Patton had answered it, so we'll move on to Derek Williams. Great presentation and examples. Question is, why were channels 7, 9, and 13 used as opposed to reflective bands to train the UNet algorithm?
Yeah, so keep in mind that what you're looking at is version 1 Gremlin, and I picked channels that are available day and night, so we didn't have to deal with the questions about how best to train models when you have data that's available or not available. So it turns out the solar reflective bands do help a lot in the daytime. Obviously, the texture in the visible band helps with identifying convection. And then the cloud particle phase and size bands also help identify convection in particular. So those bands do add value, and they are part of Gremlin version 2.
All right. Joseph, I'm going to butcher your last name, Fiore. It seems like a great product, especially for warning public about heavy rain. Question is, has there been any attempt to see how accurate this product is using rain gauge data or any ground truth?
So we have done a validation on the composite radar reflectivity, and there's a paper on that. It's linked to in the quick guide. But in terms of evaluating it for precipitation application specifically, no, that's not something that we've looked at.
Okay. Changjiang Cao. I apologize if I've mispronounced your name. What's the spatial resolution of Gremlin? It seems that 5 kilometers is a large uncertainty for a small area like this.
So the Gremlin product that you're looking at here has been provided on the nominal 2-kilometer full disk grid. You know, with UNets like that we've used for Gremlin, there is a bit of smoothing that you can see, especially compared to generative AI techniques, which are becoming more popular now. So there are things you can do to enhance the sharpness of the product, and so that's an active area of research. So yeah, you know, the ability to use Gremlin that you know, even though it is sort of coarser resolution when you're talking about a small island, you know, I guess it shows that, you know, when you don't have radar data, even synthetic radar data, you know, despite some of the limitations regarding the resolution, you know, it really does add value in terms of seeing that kind of the larger scale picture of precipitation moving towards the island, away from the island, and giving you a basic sense about its intensity. And also its ability to message with the public, because, you know, the public is used to looking at radar data, and so that's what Gremlin is emulating.
Yeah, I use an app on my PC called Photo AI that can really upscale and fine-tune images using AI, and I think that some technology like that would be pretty useful for upscaling images. Jack Sotomayor, are the AWS S3 output data public facing, and what is the format of that data if I can find a way to see it? I don't see it listed in this space, and he says HTTPS // registry.opendata.aws/. The link is in the notes.
Yeah, so I might want other people to jump in on this answer, but so you do need access to the TowerS repository on AWS. So as far as I know, it's not open to the public. You do need access to it. It comes in the format of netcdf files. They can be ingested into AWIPS. They have all the metadata for that, or using any other netcdf reader.
Okay. Matt Gunshore asks, does Pago Pago get full resolution ABI full disk, or is it reduced resolution? If reduced resolution, does that affect Gremlin?
And you'll see I answered that. So Pago Pago
okay.
has a special AWIPS subsection that gives them all full res data from the full disk.
Yeah, that's what I get for not reading ahead. Joseph Patton asks the question, it's great to see Gremlin in use in WFO Pago Pago. Kyle, you helped me with a workshop last year for demonstrating the use of Gremlin over open ocean areas in the Lesser Antilles for Hurricane Philippe. Did that use case help inform any changes to GREMLIN or its implementation at Pago Pago?
Yeah, thanks for that question. So, looking at GREMLIN for tropical cyclone cases has shown that while it does an okay job, the fact that it's only been trained on mid-latitude convection is a limitation. So, the fact that it works as well as it does for Pago Pago is encouraging and perhaps even a little bit surprising. So, with machine learning, it's really all about the data you've been trained on. And while there are some similarities between how convection looks in mid-latitudes over land and tropical convection, there's also some important differences. And so in version 2 of GREMLIN, I'm expanding the training data set to include those cases. And so I expect it'll be able to resolve that better. At CIRA, Kathy Haynes has done a synthetic passive microwave product, kind of similar to GREMLIN, but instead of training to emulate radar, you're emulating the 89 gigahertz and 37 gigahertz imagery. She's trained exclusively on tropical cyclone cases, and you can definitely see that does help with the realism in terms of structure in tropical cyclones. So it's all about the data with machine learning and bringing in those additional additional regimes and cases so that GREMLIN has the benefit of having seen those in training.
All right, I'm going to take some privilege here and ask a couple of questions. How does this product compare to the GOES-R rain rate product?
That's a good question, and I don't have a good answer for that. We haven't done that evaluation. Since it's meant to emulate radar, there would be some assumptions one would have to make. It's tempting to want to apply a ZR relationship, but you have to caveat that with all the same kind of issues you'd run into applying a ZR relationship to real radar data.
Yeah, and I'll add that the rain rate product, as far as I know, in AWIPS, I'm not sure if it's the most recent version because I know there's been a lot of updating it in the last couple of years, and getting that into AWIPS has not been a smooth process. So comparing the two is a challenge.
And I guess I should also mention to that point, Brian, that Eric Goldenstern, who's a student here at CSU, actually did take GREMLIN and trained it directly to rain data. And it turns out that estimating rain rate compared to estimating composite radar reflectivity, it's definitely a more challenging problem. You have things like low-level humidity that become more important predictors when you're looking at the surface rain rate problem. So it is definitely a very complicated and interesting question. And I think with what they've done at Pago Pago is to sort of calibrate, when they look at GREMLIN and they know what's going on, on the island, they can kind of make that calibration. So, there may be sort of a regional mental calibration that's needed for kind of the maximum benefit.
Okay. What physical signatures in satellite imagery are most influential for GREMLIN?
Yeah, thank you for that question. So the concern with machine learning is always, is it telling you something real or is it hallucinating the output? It's a legitimate question, especially with something, this critical. That's more of a problem with generative AI. So generative AI is actually trying to give you a sample from a distribution, whereas GREMLIN is more of a regression technique, trying to find the most likely solution. But I've done a lot of work using both explainable and interpretable AI techniques. And so there's kind of three signatures GREMLIN really focuses on. The first one is lightning. That physically makes sense, that strong radar echoes are tied to lightning. The next is cold brightness temperatures, and I think that's intuitive, that goes along with cold cloud tops. And then the third is strong brightness temperature gradients that you tend to see with deep convection. So those are all physically realistic signatures that GREMLIN is keying off of. Now, when you lack those signatures, say in warm rain cases, GREMLIN is going to struggle more. And so that's just something to be aware of when you're interpreting the outputs, especially in areas where maybe those signatures are less strong or not present.
All right, last question I have, and this is important for data denial. in Western region, portions of Southern region. What Gremlin products are available and how do I get them?
So right now we have Gremlin running in real time on GOES 16 and GOES 18. It's available on the full disk grid. I'm also running a CONUS Gremlin on the HER grid, just on my own personal machine here. That is open to the public. But we do have plans to extend that. So I've already done a prototype on the Korean GK2A satellite. I'm really excited about work early this calendar year to implement Gremlin on Meteosat 3rd generation, since they have a lightning imager. That could provide us important data over Africa. But in terms of right now, it's GOES 16 and GOES 18 on the full disk sector. Now, I do plan to participate in HWT this spring, and for that, we'll be bringing it onto the CONUS and mesoscale sectors. And so that'll help reduce the latency and really put it at a cadence that meets or even exceeds the radar cadence.
Awesome, awesome.
And I think I'll add to that, if you actually wanted in your AWIPS, I don't know if that was the thrust of the question, Brian, but Tower S can help with that because that's how it got into Pacific region.
Yeah, because I've got some areas in my southwestern CWA that have little, if any, radar coverage down low. It's all up high, so that would be cool. I'll check around. I'll check around on that.
And I am planning to implement it on Himawari as well. Again, the issue becomes lack of lightning data, and so there is the worldwide lightning location network WLAN. Although unfortunately there is a bit of a latency issue then. So although there are plans to put it on Himawari, I'm not sure how useful it'll be in terms of real-time applications.
Okay, I got a few more questions coming in. Eric Lau asks, are there plans to run Gremlin with JMA's Himawari? And I think you just answered that question. Joseph Patton asks, is Gremlin's use of radar down data denial situation, well, if I could read, that'd be dangerous, going to be explored at HWT this spring?
Oh, yeah, that's a great question, Joseph. I think I did partly a Kevin Teal question. So, I did submit my research to operation questions, and we found last year the radar denial experiments were really valuable. I know the forecasters maybe didn't like doing them. It's really no fun to be denied your radar, but it was helpful. So I would say I hope we will, but I can't answer that definitively, and that Kevin Teal would definitely have a role in setting that up.
Kyle, can I break in and just ask, you've mentioned Gremlin 2 a couple times, so I'll ask the question that developers hate. Is there a deadline for when Gremlin 2 will be out?
There's not a firm deadline. I'm hoping this calendar year. It's been about kind of scrapping together some funding to be able to make this all happen. But it is something I'm working on now. I have already taken initial steps looking at solar reflective bands, bringing in environmental information about surface temperature and moisture. So I have made some progress on it, but yeah, I can't give you a firm date on that. But keep up the pressure. That'll help motivate me to get this out there.
Okay, are there any other questions? We're butting up against the 45-minute time limit. Anybody else going once? Going twice? Join us on Thursday, February 6th. Dave Verdale from the New York City, New York office, and Andrew Orson from the Weather Prediction Center will discuss the New York City flash flooding event from 29 September 2023, a successful collaboration from outlook to warnings. And with that, I'll pass it back to Morris.
Thank you very much. Kyle and Scott, thank you so much for presenting at the Satellite Book Club today. And thank you too, Brian, for your excellent facilitation during the very interesting and exciting, well, for me, discussion. As Brian previously mentioned, please remember to join in a week from today to hear that presentation on the next edition of the Satellite Book Club, a week from today. Thank you all for attending this week's edition, and I hope to see you next week. Thank you.
Thank you.